Hi everyone, welcome back. Today we're down at work and we're just next door to the Bennett Brook railway sheds, and they've got their little Perry locomotive out and in steam today. So I just thought I would wander around with the camera quickly. Sorry about the sun. This little locomotive was made by Perry Engineering Works in Victoria in 1938. It's a sugarcane locomotive and it was purchased by the Inkerman mill in Queensland to haul and shunt sugarcane trains. It's just on 2-foot gauge, so it's quite a small little locomotive, this one, and it's a really nice little locomotive. This is the first time this season it's been in steam, so you can see it's still got the dome cover off while they're just doing their final inspections before the big day, their big steam day on the weekend. We'll quickly take you up into the cab. Now, this is a very cramped little cab here, and we'll have a quick look at the controls on it. So we've got a small coal bunker behind us, and there's the fire in there. We've got our gauge glasses here and we can see the water level just there, and we can notice that it is just moving up and down a little bit. The movement in these gauge glasses of the water going up and down is as important as the water level. As you're driving the locomotive, the water sloshes backwards and forwards in the boiler. If your gauge glasses are working properly, as it sloshes backwards and forwards, the water moves up and down a little bit. If there's a blockage down in these taps here, or you've forgotten to turn one of the taps on, then the water in here doesn't move up and down, and that tells you that there is a problem. Now, there was a major accident in the United States some years ago, and part of it was attributed to them not knowing that how much the water should be moving up and down, and that the gauge glass was not giving an accurate reading. We have our forward and reverse lever here. We have our vacuum brake unit here. Now, this loco doesn't have vacuum brakes on the loco. The vacuum brakes have been fitted for the carriages. The only brakes the loco has is the handbrake here, and because you can just pull this lever from forward to reverse on the go, you can actually slow down and stop the locomotive like that. Now, we've got a few gauges here. This is our boiler pressure here. This is the working pressure, or this is where the safety valve lifts. So when we're running this, we want to keep it just under that red line for maximum power. This is our cylinder pressure here. So when we are running, it will tell us how much pressure is actually getting to our cylinders, and it's an indication of how hard the engine is actually working. And it changes with the forward and reverse lever. We've got a whole bundle of notches in here. To start the locomotive, you push it all the way one way, as far as it will go. And this gives you a lot of torque, but gives you a fairly rattly engine, sort of like a little bit like pre-detonation in a petrol engine. So once we're running, we can move it 1 notch or 2 notches further forward, and we use the cylinder pressure a little bit to determine how far forward we go. We have one more gauge here that is the brake vacuum gauge. So the brake vacuum is created by a Venturi system on the outside of the cab, and when the Venturi is turned on, it's obviously not on at the moment, this gives us a brake vacuum. As we operate the lever to put the brakes on the carriages, we can see the vacuum fall away again. Now, steam engines are incredibly clever at getting cold water into the hot boiler. They have a thing called the injector, and we'll jump out and have a look at that in a minute. But to operate the injector, this is the water tap here that allows the water to flow from the tanks to the into the injector, and this is the steam tap to turn the injector on and off here. So if we just climb out, this engine is also a tank engine, so it has water tanks on the side here rather than a tender on the back. This arrangement in here is the steam injector. So when you put, it's got a series of venturis and things like that in it. When you turn the water onto it and then blast hot steam through it, it manages to raise the speed and pressure of the water enough to overcome the boiler pressure and pump it into the boiler with no moving parts. It's a really cunning way to do it. Interestingly, you need the steam, the temperature difference of the steam and the water. If you try and use compressed air to blow the water in, these will not work because the water doesn't change, the steam doesn't change size as it cools, which is part of how the injector works. One of the things about this locomotive is that it is a very small boiler and firebox, so things change very quickly on it. You can't put water and coal into the boiler at the same time whilst you're going up a hill, because you will end up with no steam. You can put one or the other in, and it means you need to watch everything very, very carefully because things change very fast on this small locomotive. It's a great one to learn on, because although things can go wrong very quickly and you can end up with no steam pressure, you can get the steam back up again very quickly. So you're not sitting out on the track for too long trying to build your steam pressure back up. This one has a very small coal tender in the back here. So we've only got 10 k's of track around here for it, and they recoal it fairly regularly every time they get down to one of the stations. Anyway, I hope you've enjoyed this look at our little Perry locomotive here. Thanks for watching, and I hope to see you again next time. Bye.